Welcome to the Calculus B section. In the previous section we learned about integrating a differential function to find the original equation, whether this was over a general region or an indefinite region. We began to delve further into and found the area between the curves or the area under a general region. However, now we are going to take it to the next dimension, literally. We're going to find the volume of a solid revolution. Similarly to finding the area under the curve, we are going to start with our function y equals f of x on an interval from a to b. Now, what's really going on here, as you can see in these two illustrations, is that we are literally rotating this function around the x-axis and creating this solid as depicted in the diagram on the right. We are three-dimensionally rotating this y equals 0.5x around the x-axis and getting a disk. The reason we are getting a disk is because there is no gap between the x-axis and the function. So if we were to say that a is 0 and b is 4, we know that our function is moving up until y equals 2 at this point. So our radius of our washer is going to be 4 because it's a distance of 4, and it would be at y equals 2. So there are three different methods for three different scenarios. Now a ring method would be if we had a graph that looked like the following. This isn't a very good graph, but there's a gap between the x-axis and the function, which means when we three-dimensionally rotate this function, there's going to be a gap or a ring space in between here. So the shell method you can use for actually both scenarios, but it is a little bit more complicated, and it is depicted as the method of cylinders. Okay. So now let's get into some equations. So the disk method is given by v equals the integral of b to a ax dx. And this is also for v equals the integral from b to a ax dy, because you can either rotate along the x-axis or the y-axis. Okay. So we know that a of x is equal to radius, pi radius squared, because this is a cyclical region. So that means that our equation is the integral of pi r squared b to a, and that would give us the volume of the solid revolution. If you would like, you could try that out for this problem. Now the ring method is a little bit more confusing because we have to account for a gap. So it's the same thing where v is equal to, from a to b, ax dx, or v equals a to b, ax dy, except our ax in this scenario is equal to the outer radius minus the inner radius squared. So that means that our formula is going to be as followed. V equals b a pi outer r minus inner r squared. Okay, now for the shell method, we can state that the area, given that the volume is equal to BA AX, or v equals a to b ax dy, our ax in this scenario is equal to 2 pi radius times height, because we're dealing with cylinders now. Now those are our three formulas for the volume of cylinder revolutions. I hope that helps, and if you need more practice problems, there's a bunch on the website. Thank you.